Welcome back, everybody. Today we're going to start comparing fractions. So yesterday I left you with a question. I wanted you to think about the patterns that you were seeing when you were comparing shaded and unshaded pieces of a fraction model. Hopefully today we can expand on some of the patterns that you found while trying your practice problems. Let's start here. Today we're going to focus on comparing fractions with the same denominator, or the total number of equal sized pieces. As you remember, the denominator is that number on the bottom. When comparing a fraction with the same denominator, the number with the larger numerator is greater. So think of it like a number line. When I look at this number line, I can tell that the larger number in the numerator is getting closer to 1 whole, or in this case, we can see it's broken up into eighths. 8/8. As the fractions get closer to 1, they get bigger. As they get farther away from 1, they start to get smaller. So if I wanted to compare, and I'll actually put smaller, greater. If we wanted to compare any of the fractions on this number line, say 2/8, and we'll just make it easy, we'll start right here, and 3/8, I can tell that 2/8 in this case is closer to 0 than 3/8 is. So 2/8 would be less than 3/8. I could do the same thing with its neighbor over here. 1/8 is the closest number to 0 right now, so it would be less than 2/8. Let's try another example. On this number line, I have 2 cupcakes that I'm going to want to label. So find the value of the orange and blue cupcake. Which cupcake represents the greater fraction? So we're going to look for the larger fraction today. Let me count my total number of equal size pieces. 1, 2, 3, 4. My shape is partitioned into fourths. So I know the orange cupcake is 1/4, 2/4. The blue cupcake is 3/4, and my 1 whole is 4/4. I still like to label that with my fraction. Now I need to compare the two fractions. Which one would be greater? 1/4 is a lot closer to 0 than 3/4 is. 3/4 is a lot closer to 1. I can also see that it takes 3 pieces that are all equal to 1/4 to get me to 3/4, while it only takes 1 piece to represent 1/4. Because 3/4 has the greater number in the numerator and it's closer to 1, I'm going to say that 3/4 is greater than 1/4. Let's try another one. Instead of a number line this time, I'm going to look at a model that has the same number of equal sized pieces. Miss Walton believes that model B, there we go, is greater than model A. Do you agree or disagree with Miss Walton? Explain your thinking. So let's start by labeling these fractions. 1, 2, 3, 4, 5, 6. 6 total pieces, so that's going to be my denominator. 1, 2, 3, 4, 5, 6. 6 total pieces, so again, that's my denominator. Now let's figure out the numerator. In this case, I'm going to look at the shaded pieces. 1, 2, 3. 3 shaded parts to a fraction with 6 equal sized pieces, meaning this fraction is 3/6. Let's check the equal size. Let's see the shaded pieces in this one. 1, 2. 2 shaded pieces out of the 6 total equal size pieces gives me 2/6. From my model, I can see that 3/6 looks larger because it has 1/6 more shaded in than 2/6. I also know that if I was looking at this like a number line, 3/6 would be the larger fraction. So if I wanted, I could just draw a number line under. I'm going to start with thirds. 1, 2, 3. Cut each of these in half. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, then this is 0. 2/6 is here on the number line, while 3/6 is here, making 3/6 greater than 2/6 because it's closer to 1 whole and farther away from 0 than 2/6 is. I'm going to draw my sign right in between. 3/6 is greater than 2/6. Another way you're going to see this on your practice problems is written in the following manner. So let's actually make some room. I know that 3/6 is greater, but I could also represent the fractions the following way. There we go. 2/6 is less than 3/6. Both of these statements are true because the mouth faces the larger fraction. When you get to your practice problems, you will see some of the fractions written where the less than sign is used.